Lesson 10.1 discusses operations with radical expressions. In this case, we're going to focus and have 3 different videos on this, first of which is dealing with adding or subtracting radical expressions. When we add and subtract radical expressions, then the radicands must be the same. And when I say radicands, I'm talking about whatever is in the square root. So we're considering something like this. If I have 2x plus 3x, I know we have 5x. So what we're going to do is transfer that over to, for example, in here, example 1, you have root 2, and root 2. They are all considered like terms because they all have root 2, which allows me to take the coefficients, in this case 5, negative 6, and 7, and put them together, which will give us a positive 6. And then you would finish by saying root 2. So again, it's like saying 5x minus 6x plus 7x, and you end up with 6x's. So we are going to approach radicals the same way. Now notice my root 2's didn't add, the inside of the roots didn't change. We're just stating that we have 6 root 2's. In the next example here, we have root 3, 15 root 3, and a negative 1 root 3. Those together give you 14 root 3's. And then we have root 5's in the middle, and you have negative 14 root 5 and 6 root 5, which gives us a negative 8 root 5. So our answer is 14 root 3 minus 8 root 5. So again, I cannot combine them because they are considered to have different roots, therefore they are not like terms. Now sometimes you have to simplify the root in order for you to do it, or for you to decide if they're like roots or not. So at first glance we notice that they are different and we cannot do anything, but we also discussed the fact that we can simplify roots. So I can take this as 2 times 9 and 3 times 3. So that's the same as root 2, or excuse me, negative 2 root of 3 squared times 2. And we talked about this in our last lesson, that the root of anything squared is the number that was being squared. So the root and square cancel each other out. So I can bring the 3 squared out as a 3, which will give me negative 2 times 3 root 2, because we still have that 2 inside it. So negative 6 root 2. Now we still have this, negative root 2, and we also have to deal with the root 8. So 2 times 4, 2 times 2. So this is the same as a 3, and on the inside, 2 squared times 2. The 2 squared comes out as a 2, and you get 3 times 2 root 2. So 6 root 2, and that's a positive 6. So if you look at all these now, before they were all different roots, now they're all the same root, root 2's. So I can take negative 1, I can take negative 6 and positive 6, and we're going to end up with negative 1 root 2. Let's look again at another question that has to deal with this simplification need. All right, so if we look at 54, we see that's 2 and 27, which is 3 and 9, which is 3 and 3. So this is the same as negative 2 root of, I have 3 squared times 2 times 3, which is, again, I can take out the 3 squared as a 3, which gives me a negative 6, and on the inside, 2 times 3 is 6. Next one is 12. I have 2 and 6, 2 and 3, which makes this negative 3. On the inside, we have 2 squared times 3. So the 2 squared comes out as a 2, and we're left with negative 6 root 3 minus 2 root 3. That's the last piece. Now here we have 2 of them having like terms, so those can go together. Those two can go together and give you negative 8 root 3. and the other one just stays negative 6 root 6. They are not like terms, and that is considered finished. This ends part 1 of Lesson 10.2.